Section 3.7 is absolute value equations and inequalities. First part here is just going to be involving absolute value equations. So I can solve equations involving absolute value. Big ideas here. An equivalent pair of linear equations or inequalities can be used to represent absolute value equations or inequalities. Absolute value equations and inequalities can be solved by first isolating the absolute value expression, if necessary, then writing an equivalent pair of linear equations or inequalities. So here's a quick recap about absolute value. Remember, absolute value is our distance away from zero on a number line. So if we have a number line, and I'm talking about the number 9, its distance from zero is 9 units away. The same distance as -9, for example, which is also 9 units away. So the absolute value of 9 is going to give me 9. Remember, it's our distance. When we drive somewhere that's 10 miles away, it's 10 miles there and it's 10 miles back. We don't say we drive -10 miles, even though it's in the opposite direction. Distance is non-negative, okay? We can't have -7 miles. We can't have -30 feet. Distance is non-negative. So absolute value of 9 is that 9 units away. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units from 0. The absolute value of -9, or the distance away from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, is also going to be 9 units. So here, when we take the absolute value of something, we get non-negative numbers. Absolute values are never going to equal a negative number. And we have two options. It's like thinking it could have been before or after. It could have been to the left or to the right. Could have been north or south. Either way, 10 miles is 10 miles, or 30 feet is 30 feet. So with absolute value, it's always our distance away from 0 on a number line, and it's always non-negative. In example 1 here, we're going to solve an absolute value equation. We're going to find our solutions, graph, and check them. So the first thing that we're going to do is we're going to get our absolute value all the way by itself. That absolute value is being added by 2, so right now we're going to subtract 2. Whatever I do to one side, I have to do to both. I get my absolute value of x equals 7. Now, in order to get an absolute value of 7, that means we're 7 units away on a number line. So inside, that number could have been 7, or whatever's inside could have been -7. Those are my solutions. We take whatever's inside equal to our number, or we set it equal to its opposite, which here is a -7. What we're saying is that our distance away from 0 on a number line could have been 7 units away in either direction, so either positive or negative. Because again, absolute value is just our distance from 0. So we have two options. It could have been to the left, it could have been to the right. So here, I'm going to put my surrounding points. So 6 and 8, -6, -8. I'm going to put a circle at -7 and a circle at 7. Those are my two solutions. It's equal to 7, so I'm going to fill it in. We always fill in if it's equal. And it's equal to -7, so I'm going to fill in there as well. We don't have anywhere to shade here. It's not an inequality. There's nothing greater, nothing less. It's just exactly those two values. Those are the only things that make it true. So again, we don't shade on our number line here because we don't have any inequalities. It's exactly those two things. We have an equals, so we fill them in, but it's just those two things that could have made this happen. Now, to check, we substitute them in. I take the absolute value of 7 plus 2 equals 9 and check. Well, the absolute value of 7, its distance away from 0 is 7 units. And I get 9 equals 9. That checks. 7 is good. Now, same idea here with -7. The absolute value of -7 is still 7 because, again, it's our distance from 0. It's still 7 units away. 7 plus 2 is 9, which also checks. So both of these are correct. Now feel free to pause here and give this a try. We want our solutions, graph, and check. So first thing I'm going to do is I'm going to get my absolute value completely by itself. It's being subtracted by 5, so I'm going to add 5 to undo the subtraction. Again, we're trying to get it to be plus 0 on this side. Absolute value of n equals 3. Now, whatever's inside my absolute value had to be 3 units away from 0 because my absolute value equals 0. So that n could have been at 3, or my n could have been negative 3, because when I take the absolute value, I get 3 for both of those numbers. They're both 3 units away. So my graph, again, I want 3 units away in both directions. That gives me 3 and negative 3. Because it's equal to these points, I'm going to put circles and fill them in. It's equal to 3, so I fill in my circle. It's equal to negative 3, so I fill in my circle. And I have no inequality symbols, nothing greater or less than, no other relationships that are going to make this true. So 3 and negative 3 are my only solutions. Now, to check that, I'm going to take the absolute value of 3 minus 5 and see if it's negative 2. Absolute value of 3, again, is its distance from 0, which is 3 units. And I get negative 2 equals negative 2. That one checks. Absolute value of negative 3, again, here is our distance away from 0. It's still just 3 units away. So I get 3 minus 5, and I get negative 2 equals negative 2. Here, they both check. Some equations have variable expressions within absolute value symbols. So the take note on page 208 talks about that situation. To solve an equation of the form absolute value of a equals b, as long as a represents a variable expression and b is greater than 0, remember we said absolute value can't be negative, we set whatever's inside equal to our number, and we set whatever's inside equal to its opposite. So solving an absolute value equation here. Starting from 100 feet away, your friend skates towards you and then passes by you. So you're here. Your friend is skating along over here, keeps skating along, and eventually is over here somewhere. Passes by you. She skates at a constant speed of 20 feet per second. Her distance d from you in feet after t seconds is given by the equation d equals the absolute value of 100 minus 20t. At what time is she 40 feet from you? So keep in mind here, guys, there's a point where she's 40 feet before you, and there's a time when she's 40 feet after you, and these are obviously not to scale here, but 40 feet in either direction. So 40 feet is what we're looking for. That's our distance from you, so that goes in for D. I'm going to have 40 equals 100 minus 20t. Think about this in terms of you being at 0. This is 40. This is negative 40 on a number line. That 40 feet is our distance away from 0 on a number line, which is 40 in either direction. So I take whatever's inside my absolute value here, twice. Because what's inside my absolute value, 100 minus 20t, could be 40, or whatever's inside my absolute value there could have been the opposite. It could have been negative 40, because when I take the absolute value of negative 40, I get 40. So either way, we don't know which one exactly, because here it happens both. It happens before you and after you. We solve both of these equations for t. So again, once we have our absolute value completely by itself on one side of the equal sign, that's when we set it equal to our opposites. T is being multiplied, so we divide. And I have two options here, 3 seconds or 7 seconds. And here it would work as an and because it happened twice. Here, at this point, would have been about 3 seconds after she started. At this point would have been 7 seconds. So started here at time 0. 3 seconds puts her at 40. 7 puts her at another 40 past you. Okay, 40 to you, 40 past you. So 2 options there. Now, another friend's distance, d, from you in feet after t seconds is given by the equation d equals absolute value of 80 minus 5t. At what times is she 60 feet from you? So feet from you is our distance. So I'm going to plug 60 in for d. 60 equals absolute value of 80 minus 5t. What this is saying, guys, is whatever's inside our absolute value here, when we took the absolute value, we got 60. So that could have been 60. Or when we took the absolute value, we got 60, so it also could have been the opposite. It could have started off as negative 60, because both of those give us, when we take absolute value, a distance of 60 units away. So again, we take whatever's inside equal to what they give us, and we take whatever's inside equal to its opposite by making it negative. And solve. Subtract 80. Whatever I do to one side, I do to both. We get rid of multiplication by dividing. Or t equals 28 seconds. So either 4 seconds or 28 seconds are our 2 options. Again, one of them's before you, one of them's after you. She's going to skate past you and be 60 feet away, whether she's before or after, so in opposite directions. Remember that absolute value represents distance from 0 on a number line, and distance is always non-negative. So any equation that states that the absolute value of an expression is negative or equals a negative number has no solution. In example 3, the first thing we're going to do is get our absolute value all the way by itself. I'm going to add or subtract first. And then I'm going to multiply or divide. We don't distribute into absolute value. We only distribute it into parentheses. So I have the absolute value of 2z plus 9 equals negative 2/3. Right now, I have an absolute value equals a negative number. No matter what I plug in for z here, I am never going to get this to work. Absolute values will never equal a negative number. So as soon as I see absolute value equal a negative number, I know right away my answer is going to be no solution. There's no number we can plug in for z to make that true. It doesn't ask for a graph here, guys, but if it did, it would just be an empty number line. Nothing on it because we have no solutions. So again here, feel free to pause if you'd like. We're going to get our absolute value by itself. And if it confuses you to have all of that there, guys, change it. Be like absolute value minus 5 equals 7. Solve a simpler problem. That's one of our problem-solving strategies. Right now it's being subtracted by 5, so I'm going to add 5. And whatever I do to one side, I do to both. Same thing over here. If it was just an a instead of a whole absolute value expression, I'd get a equals negative 2. Just like over here, a for absolute value, I get my absolute value equal to negative 2. Keep in mind though, absolute value can never equal a negative number. We can't be negative 2 miles. We can't be negative 2 feet. We can never be negative 2 any distance. So here, our answer is no solution. Once we get our absolute value all the way by itself, if it equals a negative number, we go right to no solution. That's never going to happen. It's impossible. We can't be negative 2 units away because distance is always non-negative. Quick recap here for the first half of section 3.7. An equivalent pair of linear equations or inequalities can be used to represent absolute value equations or inequalities. Absolute value equations and inequalities can be solved by first isolating the absolute value expression, if necessary, then writing an equivalent pair of linear equations or inequalities. And I will do the second half in another video.